I'm going to go over some problems from the Math 3 Unit 6 Worksheet 4. Multiplying and dividing binomial radical expressions. And we're going to take a look at number 3. What you have to do first on number 3 is to rewrite this as 2 minus square root 5 times another 2 minus square root 5. Don't try to square the 2 and the square root of 5 because you'll end up with the wrong answer. You want to rewrite it as what it means to square something, to rewrite that, to multiply it with itself. And here we're going to distribute 2 times 2, 2 times negative root 5, negative root 5 times 2, and negative root 5 times negative root 5, which is positive root 25. So we get 4. We can add the negative 2 root 5 with the negative 2 root 5 to get negative 4 root 5. And then the square root of 25 is 5. So we end up with the answer of 9 minus 4 root 5. Next, let's look at number 5. We're going to distribute 5 times 1, 5 times negative 2 root 3. Here you only multiply the 5 with the negative 2. And you get negative 10 root 3. 4 root 3 times 1 is positive 4 root 3. And 4 root 3 times negative 2 root 3. So here you multiply the 4 with the negative 2 to get negative 8. And multiply the root 3 times root 3 to get root 9. We can combine the middle two terms because they both have the same square root. So we get 5. Negative 10 plus 4 is negative 6 root 3 minus 8 times square root of 9, which is 3. And 8 times 3 is 24. And then 5 minus 24, negative 19, minus 6 root 3, and we cannot go any further than that. Next, let's look at 11. Here, notice we have conjugates, meaning everything looks the same except you have one binomial has a minus sign in between the two terms, the other one has a plus sign. And if you have this case with square roots, it will end up getting rid of the square roots, and we'll see that in this problem. So root 7 times root 7 gives us square root of 49. Root 7 times root 3, square root of 21. Negative root 3 times root 7 is negative root 21. And negative root 3 times positive root 3 is negative root 9. The positive square root 21 and the negative square root 21 add to 0. And square root of 49 is 7, minus square root of 9 is 3. So this boils down to 7 minus 3, which is 4. And as I said, when you multiply these conjugates, it gets rid of the square roots. You end up with just a real number or a rational number. Next, let's look at 17. We have a fraction, and we need to rationalize the denominator. We have that square root of 5 there, but it's as a binomial. We got square root of 5 minus 3. The trick to getting rid of the square root in the denominator is to multiply this fraction by square root of 5 plus 3 over square root of 5 plus 3, which is just 1. Right? If we multiply a fraction by 1, it doesn't change its value. But by doing this, we end up multiplying the denominator with a conjugate. When you multiply those conjugates, it gets rid of square roots, and that's what we're trying to do. So let's multiply the numerator first. So 9 times root 5 and 9 times 3. root 5 times root 5, root 5 times 3, negative 3 times root 5, and negative 3 times positive 3. So I'm going to rewrite the numerator 9 root 5 plus 27 over square root of 25 is 5. The 3 root 5 minus 3 root 5 add to 0, and so we get 5 minus 9, which is 9 root 5 plus 27 over negative 4. And we checked, can we reduce anything? We can't, so this is our final answer. (23) We're going to need to use conjugates again here, and we can simplify this a little bit first if you'd like. 27 is 3 times 3 times 3, and so we can pull out a 3 from this, and we end up with 2 plus 3 root 27 over 9 minus 3 root 3. And yes, we can do it to the other square root of 27 as well, but I'm just trying to focus on the denominator. And then we can do one more thing. We could factor a 3 out of the denominator and get 2 plus 3 root 27 over 3 times 3 minus root 3. So by doing this, we can end up multiplying by less. Our conjugate would be 3 plus root 3. And so that's one way to do this. If you didn't want to do this, these first two steps, you could have, up at front, multiplied top and bottom by 9 plus square root of 27 as well. That would work. So, multiplying this through, 2 times 3 is 6. 2 times root 3 is 2 root 3. 3 root 27 times 3 is 9 root 27. And 3 root 27 times root 3 is 3 square root 81. All over 3 times 3 is 9, 3 root 3 minus 3 root 3 minus root 9. This 9 root 27 we can change to 9 times 3 root 3, because remember we found that the square root of 27 is 3 times 3 times 3. You can pull out a 3 from that, which is the same thing as 27 root 3. So we can add the 27 root 3 and the 2 root 3. Also, square root of 81 is 9, so this is 3 times 9, which is 27. So we can add the 6 and 27. So our numerator becomes 6 plus 27, which is 33, plus 2 root 3 and 27 root 3, which is 29 root 3. In our denominator, the 3 root 3 and negative root 3 add to 0, and so we end up with 3 times 9 minus square root of 9, or 9 minus 3, which is 3 times 6, which is 18, so the denominator becomes 18. And so we get 33 plus 29 root 3 all over 18. (25) We're to find the unknown side and verify the area. So with a rectangle, you multiply length times width to get the area, and so let's let our unknown length be x. So we know that x times square root of 13 plus 3 is equal to the area of 16. So let's get x by itself by dividing by both sides of the equation by square root of 13 plus 3. And so that's our unknown length, but we always want to rationalize that denominator, so we're going to do that by multiplying by the conjugate, root 13 minus 3 over root 13 minus 3. And we get that side length is 16 root 13 minus 48, so multiplying the 16, distributing that, over square root of 169 minus 3 root 13 plus 3 root 13 minus 9, which is 16 root 13 minus 48 over here, square root of 169 is 13. The middle two terms add to 0, so we get 13 minus 9, which is 4. And we can divide. You can divide the 16 and the 48 by the 4. And we end up with the answer of 4 root 13 minus 12.